Good afternoon. Now I'm going to discuss about the topic problem solving by searches. Problem solving searches is one of the important searches algorithms. Importance of searches in AI to find the best possible solution that successfully solves a particular task. Using different searching algorithms, we can find the best possible solution. So searches is important in AI. Then coming to blind search, what is blind search? Blind search does not use any domain knowledge. This means it does any information to judge whether the solution is likely to lie. That is, breadth first search and depth first search are the two categories under the blind search. Next, blind search is a uninformed search in a class of a general purpose search algorithm which operates in brute force way. Uninformed searches algorithm do not have any additional information about state in search spaces that how to traverse the tree, so it is also called blind search. And some of the various types of uninformed searches are breadth first search, depth first search, and depth limited search and iterate deepening methods, and uniform cast search and bidirectional search. Now we can see the blind searches. One is breadth first search, that is BFS, and depth first search is DFS. Coming to breadth first search, it expands the shallowest unexpanded node first. Breadth first search is the most common search strategy for traversing a tree or graph. This algorithm searches breadth-wise in a tree or graph. It is called breadth first search. And BFS algorithm starts searching from the root node of the tree and expands all successors node to the current level before moving to nodes of next level. The breadth first algorithm is an example of general graph search algorithm. Breadth first search algorithm follows the FIFO data structure, and BFS will provide a solution if any solution exists. If there are more than one solution for a solution for a given problem, then BFS will provide the minimal solution which requires the least number of steps. And these are the two advantages for BFS, and the disadvantages are it loss of memory, since each level of a tree must be saved into memory to expand the next level. BFS needs loss of time if the solution is far away from the root node. Then in the below BFS search, we have shown the traversing of the tree using BFS algorithm from the root node to the goal state. Root node is level 0 and it ends up to level n. Now we have level 4. Level 4 BFS search algorithm transfers in layers, so it will follow the path which is shown by the dotted arrow, and transverse path will be S to A to B, B to C, C to D, D to G, G to H, H to E, E to F, and I, and then K. It ends the goal state. Next, coming to time complexity of the BFS. BFS can be obtained by the number of nodes transfers in BFS until the shallowest node, where D is equal to depth of shallowest solution and H is a node at every time, every state or every position. Then it is a space complexity. Yes, it is a space complexity memory size of frontier, which is O into B to the power of D. And completeness, BFS is complete, which means it is the shallowest goal node. It is some finite depth, and BFS will find a solution. Next, optimality. If BFS is optimality if path is non-decreasing functions of the depth of the node. And coming to DFS, that is depth first search, it expands the deepest unexpanded node first. It expands the node root node to then the leftmost child of the root node, then leftmost child of that node, and so on. Only when the search is hit dead end does the search backtracking. Backtracking means it follows the backward directions. And then BFS uses a stacked data structure for its implementation. The process of DFS algorithm is similar to the BFS algorithm. DFS requires very less memory and is one of the best advantages, as it only needs to store a stack of the nodes on the path from root node to the current node. Next, it's coming to less time to reach the goal node. Then BFS algorithm, if it transfers in the right path. Disadvantages, there is a possibilities that many states keep reoccurring and there is no guarantee of finding the solution. BFS algorithm goes for deep down searches and sometimes it may go to the infinite loop. And example is root node to the left node to the right node. It will start search from the root node S and transverse A and then B and then D and E, and after transversing to I, then it will backtrack the tree to E, has no other successor and still goal is not found. After backtracking, it will transverse node C and then G, and here it will terminate as it found goal state. Next, coming to completeness. DFS algorithm is complete within finite state space. It expands every node within a limit search tree. Time complexity of DFS will equivalent to the node transversed by the algorithm, which is denoted to O(n) power m. M is equal to maximum depth of any node and is then much larger than D. Space complexity, DFS algorithm need to store only single path from the root node. Hence, space complexity of DFS is equal to the size of the fringes set. And optimal DFS search algorithm is non-optimal as it may generate a large number of steps or high cost to reach the goal node. Then it comes to the goal node, and it starts with level 0 and ends with the final goal state. Thank you.